Hello Junior Techies, my name is Natasha Barton and I'd like to welcome each of you to this video on Lewis diagrams. In this video we will take a look at what Lewis diagrams are and I will run you through the steps that you can follow in order to draw Lewis diagrams. Let's jump right into it. Lewis diagrams can be used to show how atoms bond to form molecules. In Lewis diagrams, we represent valence electrons by making use of dots and crosses, while the nucleus and the core electrons are represented by the element symbol. For very simple molecules, we can draw Lewis diagrams by pairing up the unpaired electrons. The octet rule states that atoms tend to form bonds in ways that give them 8 valence electrons, and thus the electron configuration of a noble gas. So atoms want to be surrounded by 8 valence electrons. However, there are exceptions to the octet rule, and these exceptions include the transition elements, hydrogen, which is happy with 2 valence electrons, beryllium, which is happy with 4, and boron, which is happy with 6. One of the ways that we can draw Lewis diagrams is by pairing up the unpaired valence electrons. We're going to make use of water as an example. So, going to your periodic table, you will make use of the old group numbers in order to determine how many valence electrons each atom contains. Oxygen is in group 6 and therefore has 6 valence electrons, which we have represented around the oxygen symbol with 6 dots. Hydrogen is in group 1 and therefore has 1 valence electron. I'd like to remind you at this point that in general we will make the atom with the lowest electronegativity our central atom. But hydrogen and the halogen atoms have valencies of 1 and are therefore only able to form 1 bond. So hydrogen and the halogens tend to be terminal atoms. We can now pair up the unpaired electrons as follows, giving us the Lewis diagram of water. When we count the number of electrons around oxygen, we find that it is surrounded by 8 electrons and therefore that its octet rule is complete. Each hydrogen atom is, however, only surrounded by 2 electrons. But remember, hydrogen is an exception to the octet rule. So hydrogen is happy having only 2 valence electrons. We can also draw Lewis diagrams by making use of the steps. These steps you can find in the theory booklet, which you can download from the Junior Techie website. The example that we will use is carbon dioxide. The first step is to find out the total number of valence electrons in the molecule. We go to our periodic table in order to find out how many valence electrons each atom contains. Carbon has 4 and each oxygen atom has 6. When we add these together, we get a total of 16. Step 2 says we place the least electronegative atom at the center. But Junior Techies, remember, hydrogen and the halogens are always terminal atoms because they have a valency of 1. When we compare the electronegativities of oxygen and carbon, we find that carbon has the lower electronegativity. We therefore place carbon at the center, and each oxygen atom will become a terminal atom, and we therefore place them on either side of the carbon atom. Step number 3 says we need to place only one pair of electrons between each pair of atoms to form a bond. So we place 1 between carbon and the oxygen on the left, and 1 between carbon and the oxygen on the right. We find that the remaining number of electrons at this point is 12. Step 4 says that we need to ensure that each terminal atom, except hydrogen, has a complete octet. So we place pairs of electrons on each of the oxygen atoms, and when we count all of these electrons surrounding each oxygen atom, we find that each oxygen atom is surrounded by 8 electrons. Each oxygen atom therefore has its octet complete. At this point, we have no electrons remaining because we've used them all. Step 5 says place any remaining electrons on the central atom. But Junior Techies, remember, we've already used up the electrons. Step 6 is a very important step, which says If the central atom does not have a complete octet, we need to rearrange the lone pairs on the terminal atom to form double and triple bonds on the central atom. So, when we count the number of electrons on carbon, we find that it is only surrounded by 4. Its octet is not complete. So we move to the oxygen atom on the left and move its lone pair of electrons, one of its lone pairs, between it and the carbon atom to form a double bond. When we count the number of electrons currently surrounding carbon, we find that there are only 6 electrons. This is not enough. So we move to the oxygen on the right-hand side and move its lone pair, one of its lone pairs, between it and carbon. At this point, you will find that carbon is now surrounded by 8 electrons. This means that the octet of carbon is complete. And if you count the number of electrons surrounding oxygen, you will find that their octets are complete as well. This is therefore the Lewis diagram of carbon dioxide. Junior Tikkies, this brings us to the end of this video. Remember that in order to make sure that all of this information is retained, you need to practice as much as possible. In the next video, we will be taking a look at dative covalent bonds. So I hope that you will join me in that video. Thank you so much for joining.